Hello, this is Ms. Wynn with graphing reminders. First, a relation is a set of or collection of points, really ordered pairs, and they can give you a graph or a table. The points can be disconnected, where you say discrete, or they can be connected, which we call continuous. Now, it doesn't matter if they're discrete or continuous. If there are no x values repeating, then we call that a function. And we can check quickly to see if there's any repeat x's by doing the vertical line test. Also, we have domain and range. Domain is x, so we list all x values used. If it's discrete, so disconnected, the dots, you just manually write down all the individual x values with commas in set notation. If the relation is continuous, you can't write everything down, so we use interval notation, inequality notation, or set builder notation. And for domain, we always ask ourselves the question, how far left does it go? How far right does it go? Because x is left and right on the x-axis. The range is very similar to domain, but instead it's the y values. So again, discrete or disconnected, you manually write down all the y values. And if it's continuous, you use interval notation mainly, or inequality notation, or set builder. And instead of left to right, we say how low to how high. We always go least to greatest, negatives to positives. So make sure you do low to high, that's the main thing. So, answer the following questions for this discrete relation. So if you look at the graph, we see it's just 5 points. So first is a function. So we can drag this line, this vertical line, check. It can't touch the line more than once at a certain point. So here, it touches the line once, that's good. Here's one time, that's good. Here it touches 2 times, that's bad. Because it's touching right here and right there. So this is not a function, so I can say no. It failed the vertical line test. Alright, right here is good. And once it fails, it's over. I can also check table form. Those are all 5 points. But you see there's a repeat x. It has 1, 6 and 1, -3. So this is 1, -3. This is 1, 6. So that's why it's not a function. Alright, what is the domain? We have to list all the x values used. So the domain is, we have -5 for x, -3 for x, 1 for x, 4 for x. And it's a repeat, you can write it twice, but you don't need to. For the range, we list all the y values because it's discrete. So we have, it doesn't matter the order, you should be nice going in order. So -3's, then we have 1, then we have 2, then we have 3 and 6. Those are all the values used for y. Alright, here's another picture, but it's continuous, it's connected. Is it a function? I'm going to drag this line across. It keeps touching the line only one time. There's no double touching the line. So we're good. It passed the vertical line test. So yes. Now I'm going to say to fail the vertical line test, you have to be on top of itself, but it could be like a curve. Like this is not a function. Because I moved the vertical line test, like right here, it fails. It touches twice. So that's not a function. Alright, so things that bend like to the side, like a horseshoe or C, that's what's bad. Anyways, what's the domain? Now there's lots of x values used, so for here we have to say left to right. How far left does this graph go? Well, there is no point at -7 something, no point at -6 something, but -5 is how far left the picture goes. So I'll say the domain is to the left, -5, close because it counts. How far right does it go? Oh, this graph keeps going right, and there's an arrow right there. It keeps going. It goes on forever, all the way to infinity. Infinity is always open. Now, we could write that in inequality notation. So I can say, or, we can say x is greater than or equal to -5. So that's interval notation, inequality notation. Or we can even do our set builder notation. It's all x, the set of all x's such that x is greater than or equal to -5. Your choice, but the main one is actually interval notation. Alright, range, same idea. Low to high. How low does this graph go? The graph goes down forever to -infinity. How high does it go? The highest it goes is +9. Alright, so if I draw this line right here, there's no x, y values above that. If I try to drag it up, there's no, it'll never touch 10. It never touches 9.5. It's just all the way to 9. Alright, if I want to do inequality notation, I'll say y is less than or equal to 9. Even set builder notation, the set of all y's such that y is less than or equal to 9. And remember, when you do the interval notation, or it's least to greatest, low to high, If that's the lowest, that's the highest, you gotta be bigger than the lowest number, bigger than the first, negative infinity, and less than the highest number, so less than 9. So if you have infinity and skip that, it's like a 9 is the highest, you gotta be less than the highest, so that's why that's less than sign. Same here, this is the lowest and that's the highest. So you have to be, if you ignore the infinity, you have to be bigger than the lowest number. That's why this is a x is greater than sign. And it goes right there as well. Alright, so lots of little things. Let me delete that. So we can just leave that there. Nah, we'll delete it. Won't be lazy. Alright, delete that arrow, delete that arrow. Alright, what's next? BYOC graph align in slope intercept form. So hopefully I've seen y equals mx is b, where m stands for slope. It's the rise over run. There is a formula for slope. So if you remember, slope is m. It's m equals y2 minus y1, the change in y's, over x2 minus x1, the change in x's. If you have 2 points, you plug it in and find the slope. We'll just practice counting. And b is the y-intercept. This method is used for quickly graphing because we have a starting point, the y-intercept, and we just count using the slope. It's always up and right for positive slopes or down and right for negative slopes. So here, I see m is 2, and I'll put it right here. M is 2, that's the slope, positive 2, that's 2 over 1. And b is 4, so the y-intercept is 0, 4. That's all I need to graph. So I'll start at 0, 4, right here. Then do up 2 over 1, so up 2 over 1 right here. Then I go again up 2 over 1, up 2 over 1. Or I go down 2 left 1, 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 and so on. Now for a line, you only need 2 points, because this was to connect straight. And then down here as well. Alright, it says what's the x-intercept? The x-intercept is where it crosses the x-axis, is right here at -2, 0. What is the domain? How far left does this graph go? Well, the graph goes forever to the left. So I'll say the domain is negative infinity to the left. How far right does it go? It goes positive infinity because of the arrows. Or we say all row numbers. Range, same thing. But it's how low does this graph go? Graph goes down forever. This arrow goes down forever. So it will be negative infinity. All the way positive infinity goes up forever, or all row numbers. Alright. The last slide, standard form. That's ax plus by equals c. This form is very useful. It's very common. We use it to graph quickly because this finds us the x and y intercepts easily. It does not find us the slope easily or the, well, it does find a y-intercept. Just no slope. So note, you can solve this for y, and that would actually have the equation point slope intercept form and do what we did last slide. But try to get used to either form. If it's like this, keep it like this. Here's how we do it. We have the problem 2x minus 4y equals -8 right here. To find the y-intercept, every y-intercept has one thing in common. I mean, y-intercept could be this 0, 9, or 0, 0, or 4, 0, or -5, 0. But the thing is, sorry, reverse that. 0, -5, 0, 0, 0, 4, 0, 9. But the thing is, x has to be 0. We're going to plug in 0 for x. So 0 for x. If you plug in 0 for x, 2 times 0 is 0. All we have left is -4x minus 8. Sorry, -4y equals -8. So we can cover this up. We call it the cover-up method because anything times 0 disappears. It's gone. What's remaining is our equation. So that's what I have right there. To solve that, it's one step. I literally just divide by -4. Okay, y equals +2. That will be my y-intercept, 0, 2. I'm going to do the exact same thing for the x-intercept. So what does every x-intercept have in common? Well, here's the x-intercept, 2, 0. Here's another one, 7, 0. Maybe this one, -8, 0. But y must be 0. We plug in 0 for y. So this y will turn to 0. That means -4 times 0. Well, that's gone. This gets covered up. That goes away. So what's left is our equation. We have 2x equals -8. I can now solve that by dividing by 2. I get x equals -4. So that's the x-intercept, -4, 0, when y is 0. x is -4. Alright, you only need 2 points for a line, so I'm going to plot those two. So 0, 2 is right here, and -4, 0 is right here. I can connect that, and I have my line. To find the slope, I can use those 2 points and count, or I can use that formula from before. I'm just going to count. So from this left point, we'll read left to right. So I was saying to find the slope, we read left to right. From this left point to the right point, I have to go up 2 spaces, so positive 2. I have to go right 4 spaces. So that would be rise 2, positive over run 4. That does reduce to 1/2. So that's my slope. M equals 1/2. If you do the slope formula, you'll still get 1/2. All right. Get rid of this. What's the domain? So this graph goes left forever to -infinity. It goes right forever, positive infinity. If you see -infinity positive, you can always say all real numbers. Our range, very similar. It goes down forever, -infinity. It goes up forever, positive infinity, or all real numbers. All right. Thanks for watching. Make sure you ask any questions in class. See you later. Bye.